So, you use a computer every single day, or a phone, or a tablet. You click on things, you watch videos, you scroll through your feed. All of this happens on a screen. Every icon, every letter, every frame of that ultra-high-definition video. It's a massive job. We all know about the computer's brain, the CPU, but there's another incredibly powerful component working silently in the background. Most people have heard the term, but they don't really know what it does. I'm talking about the GPU. So what exactly is a GPU? Let's break it down. GPU stands for Graphics Processing Unit. The name gives you a pretty big clue. Its main job, its whole reason for existing, is to handle graphics. Think of it as a specialized artist living inside your computer. While the main brain of the computer is busy running your apps and your operating system, the GPU is focused on one thing and one thing only: drawing the picture on your screen. And it has to do it incredibly fast. We're talking 60 times, 120 times, or even 240 times every single second for a smooth experience. It's the reason your games look so real, and your videos play without stuttering. Before dedicated GPUs became common, the main processor, the CPU, had to do all this work by itself. It was like asking a brilliant mathematician to also paint a masterpiece. They could probably do it eventually, but it would be slow and not their specialty. The CPU was juggling everything, running the software, managing files, and also trying to draw every single pixel on the screen. This created a huge bottleneck. Computers struggled with complex visuals. The invention of the GPU was a game changer because it took that immense visual workload off the CPU's plate, freeing it up to do what it does best: think and manage tasks. This separation of duties is what makes your modern computer so powerful and responsive. The GPU is a specialist. It's designed from the ground up to perform millions of simple, repetitive calculations all at once. Imagine drawing a single frame of a modern video game. Lighting, shadows, textures, and millions of polygons. The GPU is built to handle all of that visual data in parallel. It's the difference between one person trying to build a skyscraper brick by brick and having an entire army of construction workers all laying bricks at the same time. The result is a level of visual fidelity and smoothness that was simply unimaginable just a few decades ago. This fundamental difference in architecture, a few smart cores versus thousands of simple cores, is what defines the roles of the CPU and GPU. For a long time, GPUs were all about one thing: gaming. Making games look more realistic with better lighting, higher resolutions, smoother frame rates was their primary mission. And they got incredibly good at it. The ability to render massive, detailed worlds in real time is a monumental achievement. Every reflection in a puddle, every strand of a character's hair, that's the GPU's handiwork. But then, something interesting happened. Researchers and developers realized that the GPU's unique talent for parallel processing could be used for more than just drawing pretty pictures. The same architecture that makes GPUs great at calculating pixels also makes them great at any task that can be broken down into thousands of simple, simultaneous calculations. This was a huge breakthrough. So, we've talked a lot about what a GPU does, but what does it actually look like? If you open a modern desktop PC, the GPU is usually one of the easiest components to spot. It's a large rectangular circuit board, also called a graphics card or a video card. It slots into a PCIe slot on the motherboard. Most of the time, it's the largest and often the flashiest expansion card in the system. It's a self-contained powerhouse with its own processing chip, its own dedicated memory, VRAM, and its own cooling system. The most prominent feature is the cooling solution. GPUs generate a lot of heat, especially under heavy gaming or rendering. They use large heat sinks with many thin fins, and usually 2 or 3 fans to dissipate heat. Some high-end cards use liquid cooling instead. If you remove the cooler, you'd see the heart of the card, a square GPU die, surrounded by memory chips. That's the VRAM, video RAM. VRAM stores textures, frame data, and other visual assets the GPU needs instantly. Not all GPUs are discrete. In many laptops and some budget desktops, you'll find an integrated GPU built into the CPU. Integrated GPUs are less powerful and share system memory. Not ideal for high-end gaming or heavy creative work, but for browsing the web, watching videos, and light productivity, they're fine. They're the reason thin, light laptops can drive high-resolution displays smoothly. At this point, you might be thinking, this is cool tech, but why should I, an everyday user, really care about it? The answer is simple. The GPU has fundamentally changed what we expect from our computers.